Hi, how are you all doing this morning? Well, we are going to start a brand new unit on the algebraic functions, and we will be studying the polynomial functions and the rational functions. So let's review some things that you've already actually looked at. Let's look at polynomial functions. So if I fill in the chart with the basic information I already know, then I know that f of x equals ax to the 0 just equals a. And remember, y equals a is a horizontal line, and we call this a constant function. So for y equals ax plus b, you know that that's a diagonal line. We call it a linear function. That's a first degree polynomial function. And so you know my diagonal line can be rising or falling. If h of x equals ax squared plus bx plus c, we call that a quadratic function. And you know that quadratic functions form parabolas that open up or open down. The reason I have a smiley face beside that one is that that's the kind of function that we're going to focus on for the rest of the day. K of x, you'll notice, is ax to the third power, and so it is a cubic function. If the leading coefficient's positive, you're going to count 1, 2, 3, and the right end will end up. If the leading coefficient's negative, you'll count 1, 2, 3, and the right end will point down. J of x is ax to the fourth power, which makes it a quartic function. Quartic functions are either W-shaped, 1, 2, 3, 4. If the leading coefficient's positive, your right end points up, or 1, 2, 3, 4, and your leading coefficient's negative makes the right end point down. L of x is a polynomial function to the fifth degree, so it's a quintic. If the leading coefficient's positive, then I'm going to go 1, 2, 3, 4, 5, right end up. If the leading coefficient's negative, it's going to be 1, 2, 3, 4, 5, right end down. Now, when you get to m of x or anything thereafter that has a leading exponent of 6 or higher, then you're just going to have to drop the names and call it a sixth degree polynomial function. Or if you lead with x to the seventh, it would be a seventh degree polynomial function, and so on and so forth. Now you know sixth degree functions would have to do something like 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, something like that. And then again, if you look at the very bottom, it says p of x in general is going to start out ax to the nth power, and you would call this an nth degree polynomial function. And when I graph it, in general, I will count to n as I make the turns on the graph. So that we already did when we were going over families of functions back in the function chapter. So today we're going to focus specifically on quadratic functions. And so we're going to look first at quadratic functions that are in the vertex form. And in general, I'm going to ask you to name the vertex, the x and y intercepts, and to sketch a graph pretty quickly. So let's start with what you know. Our most basic function, quadratic function, is y equals x squared. I'm going to ask you to put 3 points on the function, so the vertex is at 0, 0, and then you go out 1, up 1 from there. If I ask you to graph y equals negative x squared, like on g of x, you know that that simply turns the parabola upside down. So vertex, it's still at 0, 0, and you're going out 1, down 1 instead of out 1, up 1. H of x has the same vertex, but you're going to make it taller than normal. So instead of going out 1, up 1, you multiply and go out 1, up 3. That's going to make it look taller and skinnier. We've talked about all these transformations, so this should be pretty quick for you. On K of x, this is the same parabola but moved up 2. So the vertex is at 0, 2, and from there you go out 1, up 1. So let's go back and let's fill in the other information, because I'm going to ask you to do the graph and vertex and roots and y-intercept. So on this one, the vertex equals 0, 0. The same thing is true on G of x. Correct my little mistake there. The same thing is true on H of x. And then we said that the vertex on K moves up 2, so that goes to 0, 2. These are all going to be really easy on this section. Anytime you have vertex form, it's really an easier problem. So the next thing that we're going to do is look at the x-intercepts. And I can tell on this one that the x-intercepts is going to be at x equals 0, and that's a double root since the parabola touches or brushes or kisses the x-axis but doesn't cross through. The same thing is true on the next two as well. So I'm going to say x equals 0 is a double root. X equals 0 is a double root. But now, on K of x, I don't need to do any algebra work where I'd wind up getting some sort of imaginary solution. Instead, I'm just going to say there are no x-intercepts because the parabola does not touch or cross the x-axis. Last but not least, y-intercept on all these is really easy as well. So I'm going to say the y-intercept is the point 0, 0, or y equals 0. On this one, the y-intercept also 0, 0. And then on this last one, the y-intercept is 0, 2, the same as the vertex. I'm going to pause just in case my voice and my writing aren't synced to give you a chance to catch up. All right, let's move forward in your skeleton notes. Now we're going to start looking at some that are perhaps a little more involved. We've still got vertex form, and when you have vertex form, life is good. I can go ahead and start with the sketch, and then filling the information in is a breeze generally. So on J of x, do you realize that the parabola moves left 4? So the vertex goes back to negative 4, 0. And then the A value is still 1. So it's still out 1, up 1. And you've got yourself a good, quick sketch. On L of x, I can see that the parabola moves right 1, down 1, 2, 3. On this one, guys, the parabola is upside down. And let me remind you of something really quickly. If you have, I'm going to erase this, but just watch, just so I can remind you. If your A value is 1, then out 1, up 1, because 1 squared is a 1. Out 2, up 4, because 2 squared is 4. From the vertex, out 3, up 9, because 3 squared is 9. If you have negative 1/4 as your A value, then in general, you're going to go out 1, down 1/4. Because you're going to multiply the 1 by negative 1/4. I'm going to go out 2, down 1, because 4 times a negative 1/4 is negative 1. This is the one I'm going to use because that gives me nice, neat whole numbers to plot or integers to plot. Here I would go out 3 and I would go down 9/4 from the vertex. So remember those movements because that allows you to sketch really fast without having to do a whole lot of work, and that's what our goal is. So again, I'm going to say if I go down -1/4, I'm going to go out 2, and normally I would go down 2 squared or down 4, but I'm only going to go down 1 because that's a fourth of 4. So out 2, down 1 from the vertex. Now, m of x, I'm going to go left 5 and down 6. Now, on this one, I also need to go out 1, but I'm not going to go up 1. I'm going to go up 1 times 2. So out 1, up 1, 2 on either side of the vertex. Out 1, up 1, 2. Now I can go in and fill in the information pretty quickly. So I already know from J of x, I've already even discussed this, that the vertex is equal to -4, 0. On L of x, the vertex is equal to right 1 down 3, so 1 -3. And on M of x, the vertex is equal to left 5 down 6, so -5, -6. Those are easy. Let's look at the x-intercepts. I can tell on J of x, since the parabola is just sitting on the x-axis, I have a double root again, like I did on the previous slide. Now, on L of x, I don't need to do algebraic work and come up with imaginary answers. I can tell from the sketch that there are no x-intercepts. So use your sketch to help you speed up your work. You don't need to do algebra if you can already see the result. Now, on M of x, I can see that there are x-intercepts, but I can't tell exactly where they cross the x-axis. So I need to do the work. And anytime you want to find x-intercepts, you set y equal to 0 and you solve. Don't square x plus 5. That would be making this way too difficult. Instead, isolate the x plus 5 squared. So that's equal to 6 over 2. And then take the square root of both sides. And subtract 5. Now you can't do much better than a reasonable estimate on your x-intercepts when you've got your rationals like this. I know that square root of 3 is 1 point something, so -5 minus 1 point something would be -6 point something. 1, 2, 3, 4, 5, 6, 7. So -6 point something would fall somewhere between -6 and -7. -5 plus 1 point something would be -3 point something. 1, 2, 3 point something. That would be somewhere between -3 and -4. And so if I simply extend my parabola, my picture's not perfect, but I can tell that those values make sense. They're reasonable. I also can tell that from the axis of symmetry here, I'm going to go 1 point something to the left and 1 point something to the right to plot my x-intercepts. Okay, last but not least, I am going to find my y-intercepts, and you've always got a y-intercept. Now, on J of x, my y-intercept is way too high to picture, but I know if I simply plug 0 in for x, I can calculate y. 0 plus 4 is 4, squared is 16. And so 0, 16 would be way up here, way up here somewhere, and that would be higher than what I reasonably need to make tick marks to. I can tell that it makes sense. Now, on L of x, I can actually see my y-intercept. It looks like it's around -3 and 1/4, but let me check and see if that makes sense. So if I plug 0 in, 0 minus 1 is -1, squared is positive 1. So negative 1/4 times positive 1 is negative 1/4. Negative 1/4 minus 3 is negative 3 and 1/4. You might also say 0 comma negative 13/4 and write it as an improper fraction. So on your y-intercept, on the last one, again, I can tell that it's going to cross the y-axis, but it's going to be so far up, it would be off the Promethean board. So I'm expecting it to be a very large number. Let me see if I plug 0 in. 0 plus 5 is 5. Squared is 25. 2 times that 25 is 50. 50 minus 6 is 44. So again, that's way higher than what you would need to reasonably make tick marks for. It makes sense that it's going to be that high, but I don't have to show it. So I am telling you that when you're sketching your parabolas, a small, quick sketch is enough. Give me 3 specific points and move on. Now we're going to work on those that require more algebra. So whether the book tells you to or not, I always want you to start with writing the equation in vertex form. So how do you do that? The answer is complete the square. So I'm going to start here, and if you want to sub in y for n of x, that's fine. I need to remind you that when you complete the square, you complete the square for the x's. So the 5 is in your way. Move it. So I'm going to say y minus 5 plus a space to complete the square equals x squared minus 6x plus a space to complete the square. So when I complete the square, half of the 6 is 3. 3 squared is 9. And then that's what you put on the left-hand side as well to balance the equation. Clean up. So the left side condenses into y plus 4. The right side condenses into x minus 3 quantity squared. So y equals x minus 3 quantity squared minus 4. Let's do the complete the square work on P and Q while we're here. Hopefully that will help you move a little faster with these if we do the same concept over and over. Now on this, once again, I've got to complete the square for the x's, so the 19's in my way. Move it. So I'm going to say y minus 19 plus, now let me remind you, you have to only complete the square for 1x squared. So I need to factor the 1/2 out. Now watch, a lot of people misfire and say half of x squared plus 3x plus a space. That's wrong, guys, because if you redistribute, you're going to have 1/2 x squared, which is correct, but then you're going to have 3/2 x. You didn't want 3/2 x, you wanted 6x. So if you factor a fraction out, the middle term needs to get larger, not smaller. So what I need to put in instead is 12 right here. So then it's 1/2 x squared, half of 12x is your 6x, and that's what you want. So now we're ready to complete the square. Half of 12 is 6. 6 squared is 36, and be very careful. You don't put 36 right there. That's what people do when they misfire, so don't do that. Okay? It's not 36, it's half of 36. So I need to put 18 right there in order to balance the equation. So clean up the left, y minus 1. Clean up the right, 1/2 times x plus 6 quantity squared. And now I'm finished and I'm back in vertex form. All right, last but not least on Q of x, again, you need to complete the square for the x's, so the 3 is in your way. Move it over and make a space to balance your equation. One more time, I cannot complete the square leading with a negative 3x squared. I need just a 1x squared, so factor the negative 3 out, and you'll have x squared plus 2x plus a space to complete the square. I'm going to double check. That gives me negative 3x squared. Check. Negative 3 times 2 is negative 6x. Check. It's time to complete this square. Half of 2 is 1. 1 squared is 1, and then be very careful you put negative 3 here, because it's negative 3 times the 1 gives you negative 3. So that's the total new information on the right that you got to balance on the left. Clean up. Y equals negative 3x plus 1 quantity squared. Now I'm going to go overboard on my work on the left-hand side on n of x, because I want you to see some extra stuff. Before we do, let's go ahead and get back to the sketch, because now that you've got vertex form, you can sketch and then use your sketch to help you trim the work out on your x-intercepts and y-intercepts perhaps. So on this first one, I can see that I need to move right 3, down 4. And then I can go just out 1, up 1 in both directions, since it's just 1x squared. On the next one, I can see that I'm going to move left 6, up 1 for my vertex. And then I also see that I have to open right side up, but I have to multiply by 1/2. So I could go out 1, up 1/2 instead of 1. I don't like that because that's a fraction. Instead, let me think, out 2 from the vertex. Normally I would go up 4 because 2 squared is 4, but let me just go up 1/2 of 4. So just out 2, up 2 in both directions. And then on the last one, I'm just going to go left 1, and then out 1, down 3. All right, vertex is easy on each of these. You've already named that the vertex on this one was right 3, down 4, so 3, negative 4. The vertex on this one was left 6, up 1, so negative 6, 1. And the vertex on this one was left 1, so negative 1, 0. Now, let me remind you that if you're in vertex form, you don't need to do any work to see the vertex. All right, but I want to remind you there is another way to find vertex that you'll especially use on word problems. So on n of x, remember the other way that I could go through to find the vertex is I could use the original standard form, and I could say x equals, and do label, if you're finding x, label x equals negative b all over 2a. Well, negative b in this case is 6, and 2a is 2, and that would give you 3. And then you would have to say, well, n of 3 is going to be 9 minus 18 plus 5, and negative 9 plus 5 is negative 4. So that's another way for me to find the vertex. But guys, if you're doing vertex form first, you don't need to do that work on these basic graph problems. That work you can do, however, on word problems, because on word problems I don't expect you to find the vertex form first. I'm going to eliminate that work no, I'll keep it. That way if you look at the notes online, you'll be okay. All right. On the next step is to find the x-intercepts or the roots. And so here, the x-intercepts, I can see that the graph does cross the x-axis twice, but remember my graph is probably not the most accurately drawn graph. So I can't for sure see where it crosses, so let me do the work for it. So on this one, I know that the x-intercepts, I could either say that x squared minus 6x plus 5 equals 0, or I could say that x minus 3 squared minus 4 equals 0. So you can set standard form or vertex form equal to 0. I personally prefer vertex form if I've already got it. So I'm going to add 3 after I take plus or minus the square root of 4. So I'm seeing the x-intercepts are at 5 and 1. And I'm looking at my graph and I realize I don't have it quite scaled correctly. If I've got 1, 2, 3, 4, 5, my right hand side turned out pretty well, but my left hand side is not so clearly drawn. Looks like maybe I got my scale off a little bit. So let me just fix it and try to make it look better. It's still reasonable. I just maybe got in a hurry when I was drawing that side. Now, if you did complete the standard form, then I would notice, oh, this factors when you're solving the standard form equation. And it would have to factor into minus 5 minus 1, so x equals 5 and 1. So either way is pretty okay. But if I've got vertex form, I do think that's faster. Let's look at the next one, and I see that the x-intercept here is just going to be none because the graph clearly does not cross the x-axis. Now, if you did the work, then you might set 1/2 x plus 6 quantity squared plus 1 equal to 0. Solve for the x plus 6 squared, and it's going to be negative 1 divided by 1/2, which is also equal to negative 2. But then I see that would give me x equals negative 6 plus or minus the square root of negative 2. That's imaginary. If you get imaginary answers, then you've got to stop and go, wait a minute, that means there are no roots, no x-intercepts. So if you do the work and get an imaginary answer, then you should look back at the graph and go, whoops, that means there were no roots and I didn't have to do the work in the first place. All right, on the last one, I can see already that the x-intercepts are just the same as the vertex, so x equals negative 1 must be a double root. All right, last but not least, the y-intercept. Okay, on this first one, let me talk you through, because it does not matter which form, standard or vertex, you plug 0 in for. So if I plug 0 into the original form, I would say n of 0 is 0 squared minus 6 times 0 plus 5, which is 5. If I plug it into the vertex form right here, then I'm going to say 0 minus 3 is negative 3, squared is 9, 9 minus 4 is 5. So either form you plug into for the y-intercept is going to be quick. On this one, on P of x, I can see that the y-intercept is going to be a pretty high number because I can see my red parabola will cross the y-axis higher than what I've drawn. I'm going to just plug it into P of 0 into the standard form because I can go straight to the c part of ax squared plus bx plus c. Last but not least, for Q of x, since I do have the standard form, let me just look at 0, negative 3 and move quickly. So there's the work that you'll do. Let me remind you, you don't have to do vertex in 2 different ways. You don't have to do x-intercept in 2 different ways. I just showed you 2 different ways on n of x just to remind you that you do have options. Let me pause and make sure you're caught up to this point. You have done all of this before you ever got to me. You did it some in Algebra 1 and then heavily in Algebra 2. So what we have done up to this point should be a review. And you should be moving faster and faster through the problems than what you would have in Algebra 1 or Algebra 2 because this is not new at this point. All right, so let's start working backward. What if I give you information about the parabola and ask you to work backward to the equation? Well, it says first sketch the parabola. So if I sketch the parabola, then I'm going to say vertex is at 3, 2. And the parabola passes through or contains the point 1, negative 1. So I can see from the vertex I've counted out 1, 2, and down 1, 2, 3. That means I can count out 2, down 3 in the other direction as well to create that symmetry about the vertical line of symmetry? So I know a couple of things. I know that the parabola needs to have a negative a value because it's upside down. And it looks like the parabola is going to be a little shorter and wider than a normal parabola. So I'm expecting the a to be less than 1. Okay, here's what you want to look at. If you are given vertex that start in vertex form. Vertex form is a times x minus h quantities squared plus k. Start there. Well, I know that it's going to be x minus 3 quantities squared plus 2 because that shows that my vertex moves right 3 up 2. So what do I do to find a? That's where you come along and plug in this extra point that I gave you. So I'm going to plug negative 1 in for the y and positive 1 in for the x and solve for a. So 1 minus 3 is negative 2 squared is 4. So that reduces to 4a plus 2. So 4a equals negative 3. A equals negative 3/4. And again, I predicted that a would be negative and that it would be a little less than 1. And sure enough, it is. So now, in vertex form, my final answer is a, or y equals negative 3/4, x minus 3 squared plus 2. If I ask you for vertex form, you're done. But notice this one says finish in standard form, and that way we get some practice with going to standard form. So we worked on completing the square to go from standard back to vertex. What do you do to go from vertex to standard form? Just follow the order of operations. So I'm going to square first, x squared minus 6x plus 9. I'm going to multiply next. So negative 3/4 x squared. Negative 3/4 times negative 6 is what? 18/4 or 9/2. And then negative 3/4 times 9 is negative 27/4. And I'm going to have to add 2. So I'm going to write 2 as 8/4 just to make my fraction work easier. So my standard form, negative 27 plus 8 is, I believe, negative 19/4. And there you go. Okay? So, second parabola, I'm going to start similarly. I'm going to sketch the parabola first, just to get a feel for what I'm dealing with. So the parabola has roots at negative 4, 0. Roots, x-intercepts, zeros, solutions. Those are all interchangeable for the most part. Now, if the parabola has its roots there, then if you move inward from negative 6 and 4 evenly, so I'm going to move to negative 3 and 5. I'm going to move to negative 2 and 4, negative 1 and 3, 0 and 2. Then my fingers meet in the middle at x equals 1. So I know the vertex is somewhere along that axis of symmetry. From the axis of symmetry, count left 1, 2, 3, 4, 5 to the vertex or to the root. And to the right from the axis of symmetry, 1, 2, 3, 4, 5 to the root. So I do know something about the vertex. The parabola passes to the point negative 1, negative 4. So I've got a point there to the right of the axis of symmetry, 2 tick marks. So that means I could do the same thing on the other side. And again, right now what I'm doing is just estimating where the vertex is. I'm not for sure where it is. I'm just drawing in a reasonably shaped parabola. It's not perfect. So, the next thing I need to do is set up my equation. Now, here's what I know. The a value will be positive, and this parabola appears again to be kind of short and wide. So I'm thinking I'm going to have an a value that's less than 1. I'm not sure, but that's just what that seems to look like. But here's what you need to know. If you know the roots or the x-intercepts, then the form you should start with is factored form. Factored form is a times x minus one root times x minus the other root. That's the general form for it. Because, again, let me reiterate, if you know that there's a root at -4, then one of your factors is x plus 4. And if there's a root at 6, the other factor is x minus 6. So it wouldn't make sense to set up vertex form because I don't know the whole vertex. But I can set up factored form. Now I'm going to go back and use the extra point to help me find a. So for y, let me plug in -4. For x, I'm plugging in -1. If I clean up, that's going to give me a times 3 times -7. So -4 equals -21a. A then is going to be positive 4 over 21. So my gut feeling was right that the a was less than 1, making the parabola short and wide, and I knew it was going to have to be positive. So the factored form is y equals 4 over 21, x plus 4, x minus 6. And I might sometimes ask you to just write factored form and be done with it. If, however, I ask you to go to standard form, like again, I ask you to go to standard form up here, so what do? I just multiply it out. There's no one right order, but for me, I think it's easier to FOIL first. So x squared minus 6x plus 4x is minus 2x, minus 24. And then I distribute the a. For me, I think that's the easier choice. But you could distribute the a to the first set of parentheses first and then FOIL if you want. So let's see here. That's going to give me -8 over 21x. And so I need to do 4 over 21 times 24. I'm going to reduce first. So 3 goes into 7, or 21, 7. 3 goes into 24, 8. So that's looking like -32 over 7 to me. I'm double checking my work, and that looks right. Just wanting to double check before I left this slide. Okay, are we all right? Again, I'm pausing just in case my voice and my handwriting aren't synced and you're a little bit behind. Now we're going to wind this up with applications, and I need you to get your calculators out because with the applications you're going to have a lot of messy numbers. You don't need to graph these. You don't need to put them in vertex form. You just need to answer the questions. Now, let me say a couple of things. Whenever you do applications, a lot of people freeze up on word problems, but you need to realize something. With quadratics, the most frequent application, look here, the most frequent application is just asking you to find the vertex. And you'll have to read the problem to know whether they want the x-coordinate and or the y-coordinate of the vertex. But that's the most frequent application question you're asked. The second most frequent then would be to find the roots. And that would be if you've got like projectile motion and you want to know where a ball that's been kicked, where it hits the ground, or where a cannonball that's fired plunges into the water. We're going to see one of those. And then sometimes the problem just says, okay, plug in an X and get a Y, or vice versa. I think you've got a problem that has something to do with average marrying age of grooms and brides. And so you'll see one of those there. Now, if you read this problem, the marketing department at Texas Instruments has found that when certain calculators are sold for a price P, the revenue R is given by this messy equation. So what price should be charged in order to maximize revenue? Here's what I want you to realize. If I'm asking you for a max or a min, think about what the original parabola looks like. And I can tell that y equals -152.63x squared is an upside down parabola. If it's an upside down parabola, I don't need to know what it looks like exactly. that just reminds me that I will get a max at the vertex. And so this question, part A, part 1, is just asking you to find the vertex. So if I start and say, well, to find the vertex, it's not in vertex form, so I'm going to say x equals negative b over 2a. I don't have x, I have p. So p equals negative b over 2a. So use your calculator and figure out what that gives you. So I'm using my calculator. You plug it in at the same time. Nothing complicated about this. You don't need to show me a whole lot of work, but you need to show me your setup. I'm getting on this one 6620, and when I round, now why am I rounding to 2 decimal places instead of 3 decimal places? Well, because it says what price should be charged. So this is a dollar and cents answer. So let me put a dollar and cents answer. Put your dollar sign on there. I'm going to double check that. Because I don't want to leave a mess of something that I can't correct since I'm not actually with you. Okay, I plugged it in a second time and got the same thing. I just wanted to double check. Now, on part 2, it says if that price is charged, then what's the maximum revenue? So remember that this vertex or this max that I mentioned up here is going to be of the form P, which is in place of X, comma R, which is in place of Y. So if I want max revenue, I just need to plug P in and get R. Do I need to show you? Do I need you to show me a lot of work? No. If you want to show me, Miss Porter, I am plugging in P equals 6620, then write R of 6620. That is the beauty of function notation. I don't need you to write out negative 152.63 times 6620 squared plus, and on and on and on. Just do that on your calculator, guys. So I'm punching it in. I hope you are punching it in at the same time. Because you're going to do better if you're not just sitting and waiting. If you're actually doing it for yourself, all this is going to be way more clear. Okay, when I plug all that in, I'm getting $668,906.25. I'm going to double check one more time since, again, you are not with me at the moment to correct me just in case I've made a calculator punch error. I've gotten the same exact answer a second time. So we'll roll with that, and there you go. Okay. So the price that should be charged is $66.20 in order to maximize revenue at $668,906.25. Now, a lot of you might be thinking, well, I could have done that on my calculator, and you can do it on your calculator in order to check your work. But remember, the only time you ever do work exclusively on calculator is if I say this is a calculator problem, or if you try some algebra, but there's no algebra to get you there. All of these, I'm wanting you to show some work, but it's not a lot of work if you notice. So let's read this problem. You've done one like this before because we did a problem about a play area behind a house using the back wall of the house as one side of the fenced-in area. So this problem is real similar to that one. So Farmer Brown has 2,000 yards of fencing to enclose a rectangle. For whatever reason, I guess because there's a guardrail around the highway, and so he doesn't need to fence the guardrail side, and runs along one side of the property. What's the maximum? Maximum! I see that again. What's the maximum area he can enclose? I'm thinking this is a vertex problem, but let's set it up and see if that makes sense. So I don't know what the dimensions of the rectangular area are, so I can label the long side x and the two sides something else, or I can name the two sides x, and then I can label the long side something else. So it's going to be 2,000 minus 2x yards of fencing. Now, I know that since I'm trying to maximize the area, this is an area problem. And I know in general that the area for a rectangle is length times width or base times height. That's not a function. If I say area of x only, then I can replace it and say 2,000 minus 2x times x for my base and height. Now let me go one step further. I'm going to distribute backward and get negative 2x squared plus 2000x. And remember, I was thinking that this was just a find the vertex problem. And if you look at the negative 2x squared part, you know for sure that the parabola is upside down. Therefore, it will have a max. The max is at its vertex. And the vertex will have coordinates of x, comma, a for area. So we're definitely just doing a vertex problem again. So I'm going to launch into vertex work. X equals negative b all over 2a. That looks like to me it's going to give me 500, and that will be yards. Now, the question is, once you do this work, sometimes it wants the dimensions, other times it actually wants maximum area. So stop and reread the problem before you finish. So it actually says, what is the maximum area? It does not ask for dimensions. So if I'm going to do the max area, I need to do A of 500. Again, you're showing me that you're plugging 500 into the original problem. So I do not need you to show me work beyond that. But notice, if I plug in on this one, then I can say 2,000 minus 1,000 is 1,000 times 500. And then it does look like you've gotten dimensions. 1,000 by 500 would be the dimensions of the lot. So that would be 5 with 1, 2, 3, 4, 5 zeros. So I'm saying that the maximum area here is 500,000 square yards. Do you have any questions about that, gang? I am double checking, if you're wondering why I'm pausing. I am double checking to make sure I didn't do any goofy number crunching. So 2,000 minus 1,000 is 1. Yeah. Okay, that's all good. Just double checking, and it gives you a chance to catch up just in case you're a little behind. Okay, guys, we have got one more problem that we're going to do, and then you are ready to rock and roll on assignment 15, I believe is what we're up to. So projectile motion, let's look at the cannonball problem. So a cannonball is fired from a cliff 500 feet above water level at an angle of inclination of 45 degrees with a velocity of 400 feet per second. That's all Jim Dandy, and maybe in physics you'd be asked to set up the equation yourself, but you don't have to do all that here. All you have to do here is go straight into the work. So look at the equation that says your physics teacher will help you with that. You can look, the negative 32 has to do with gravity being an acceleration of negative 32 feet per second squared. 400 has to do with the initial height. And then the 400, has to do with the velocity. The 500 has to do with the initial height of the cannonball. So one thing I will say is that I do not want to work with an equation that's still in this messy form. So I'm thinking I can clean up that negative 32 over 400 squared. I'm doing scratch work, which I'll erase. Well, that's negative 32. 400 squared would be 16 with 4 zeros. Now, if I reduce, 32 goes into 32 once. And if I say 16,0,0,0 divided by 32, I get 5,000. So let me rewrite this as negative 1 over 5,000. x squared plus x plus 500. Because from a math teacher's point of view, you want to work with the simplest equation. Your physics teacher wants you to set it up and then probably use programs to do the math part of the problem, and I'm coming from the other direction. I don't care if you set up the equation. What I need you to do is show me the math that goes with working with the equation. So what is the max height of the cannonball? So again, we're looking at max. That should seem familiar. We've done that a time or two now. And so part 1 is asking you, please deal with the vertex. So x equals negative b, so negative 1 all over 2a. 2a would be negative 2 over 5,000. That's going to be positive, and 1 over a fraction simply means reciprocal. So I'm getting 2,500 feet. Now, is that the max height? No. Okay? I want you to consider that the water is the x-axis and the edge of the cliff where the cannon is sitting is the y-axis. And so the x-coordinate that I just measured is, if we say that this is the max, and you'll notice that my picture is way not to scale, but I want the max height above the water level. What I just found was the distance from the edge of the cliff out to the vertical line where the max height is. So I still have to find the max height. That means I need to find h of 2,500. Tell me that you're finding h of 2,500, but do the rest of the work now on your calculator as far as plugging in. So negative 1 divided by 5,000 times 2,500 squared plus 2,500 plus 500. I'm getting 1,750 feet as the max height. So my picture is desperately out of proportion because I'm saying from the cannon to the vertical line is 2,500 feet, but from the top of the cannonball's path to the water is 1,750 feet. So my picture is way out of proportion. It suffices, but it's out of proportion. Okay, so part 2, how far from the base of the cliff will the ball plunge into the water? Okay, so if I ask you how far from the base of the cliff will the ball plunge into the water, what I'm looking at, guys, is measure from the x-axis or from the y-axis all the way to here. You're asking what's that rightmost root? What's that rightmost x-intercept? So on the next one, I'm finding x-intercept. So I've got to set my equation equal to 0. The height of the cannonball when it hits the water is 0. Now figure out where that happens. So guys, regardless of how you solve this equation, there is no need to work with messy fractions. So multiply everything by negative 5,000 so that you'll get positive x squared negative 5,000x minus 500 times 5,000 is 25 with 5 zeros. So 2,500,000 equals 0. Now, do you want to complete the square or do you want to use the quadratic formula? Well, I'm going to suggest you might, either's fine. You can deal with it real simply. But if you'll set up the quadratic formula for me so you let me know what you're doing, then you can do the rest of the work on your calculator. So x equals negative b plus or minus the square root. So that's 5,000 squared would be 25 with 6 zeros. I've done b squared minus 4ac all over 2a. So you've set it up and I know what you're doing now on your calculator. So how about giving me a couple of decimals, each one to 3 decimal places? I am still punching in. Realized I made a button punching error. Hopefully you are already there. Okay, I'm getting 5,458.0398 would be 040 rounded to 3 decimal places. Feet from the cliff for my positive answer. Now, I don't need the negative answer, but I'm going to write it and then we'll talk about it real briefly. So let's see here. Let me get it real fast. I'm getting something like negative 27,080.340. Something does not feel right about that. Let me try that one more time to see if I boo-booed. Well, now I'm getting all kinds of strange things. So 25 million plus 4 times 2,500,000. And I'm going to take the square root of that. No, no, no. Yeah, I had way too large a number. I knew something didn't feel right about that answer. Good thing I'm double checking. Sorry I'm taking some of your time. Yeah, that seems more right. Because something about this just seemed way too big. My bad. So I'm getting negative 458.040 feet. And of course, the negative answer does not make sense in the word problem. But if you were to complete the parabola back here, it's just saying that the rest of that parabola, the cannonball, if it could have gone from the ground up, would have started at negative 458.040. So that makes sense. All right, so on number 3, how can you use your calculator to verify both results? All right, we're going to have a little fun with our calculators. This time I'm actually going to work with you so you can see what's going on. And this will be it. So on your calculator, if you would, notice that to the left of Y1, I have changed it to where it'll be the little line with the circular tail at the end. And that just makes it kind of fun. It's not necessary, but it's just fun. Because remember, this is a cannonball that we're firing. So negative 1 divided by 5,000 parentheses x squared plus x plus 500. Now, let's see here. I need to go to my window and think about what it's going to take to show this. So, my last answer was that the cannonball plunged into the water about 5,500 feet from the cliff. So I'm thinking, whoa, Go back. I'm thinking that X min should be 0, but X max, if I've done this right, should be 5,500 feet. Or you could do 6,000 feet. That would be fine too. X scale clearly needs to be, oh, I'm going to make it around 200. 300, 200, 300, something like that. Now Y min needs to be water level, so I'll make that Y min is 0. Y max, now if you'll look at our work, we said the maximum height of the cannonball was 1,750 feet. So let me make Y max 2,000 feet. And I'll do Y scale by 100. So when you hit graph, now you see the cannonball actually flying through the air. That's the only reason I changed, because I thought it would be more fun. So here it goes. Woo! Okay, so at this point, how can we verify the answers? Well, let's actually calculate our vertex and calculate our x-intercepts on the calculator. So let's trace. I'm going to arrow to the left, and I'm watching my y values get as high as they possibly can be. Well, it looks like that the highest was 1750 exactly. Let's verify that that's actually the max. So second, calculate maximum. Left bound, yes. Arrow to the right twice. Right bound, yes. Enter. So the maximum does turn out to be 2,500 feet from the cliff and then 1,750 feet above the water. Okay, so trace again. Let's take that cursor until we watch the y values go negative. So down we go. My y values go negative. Now, okay, so back up to the left. Second, calculate. I want the 0. Enter. I'm on the left side. Arrow to the right, so the the cursor pops to the right and below. Negative y value. Enter. Enter. So that's giving me approximately 5,458.040, which is what we got. So we sure enough now have verified. So notice that I didn't say find the work on your calculator, but certainly you can use your calculator to verify your answers. So guys, you're ready for A15, and you can work together in your groups or work quietly if you've got any time left today, and we'll get started again tomorrow. But note, we're going to go a little out of order tomorrow. We're going to skip to the assignment on complex numbers to make things a little easier for you over the weekend. Have a great one.